December 1811. The Mississippi River reversed, forests vanished overnight, and tremors rang church bells 1,000 miles away. It was shocking proof of the new Madrid Seismic Zone's raw power at the nation's heart. More than 2 centuries later, scientists record thousands of earthquakes here every decade, warning that this ancient rift still builds toward another catastrophe. Why does America's deadliest fault lie hidden in its quiet heartland? And could it tear the country apart again? At 2 in the morning on December 16, 1811, a violent earthquake struck near New Madrid, Missouri, tearing open the earth and sending shockwaves across the continent. People jolted awake to the sound of trees snapping and the ground rolling beneath their feet. Riverboat captains recorded the Mississippi surging upstream, its current reversing for minutes as the riverbanks collapsed. By dawn, entire forests had disappeared, submerged as the land sank and water rushed in. In northwestern Tennessee, what had once been dense woods transformed into Reelfoot Lake, a new body of water born overnight. The shaking did not stop with a single event. On January 23, 1812, a second massive shock followed, and then a third on February 7, 1812. Each quake unleashed more destruction, toppling chimneys in Cincinnati, cracking the earth open in Kentucky, and sending tremors so far that church bells rang in Boston, nearly 1,000 miles away. Diaries from settlers describe the terror. The earth rolled and heaved, birds shrieked, the river ran the wrong way. Swamps appeared where once there were forests. Riverboat logs tell of waves so large they washed vessels ashore and left islands vanished by morning. A regional historian recalls that for months, the ground never truly settled. People lived with constant aftershocks, never knowing if the next would be the last. The scale and reach of these quakes left a lasting scar, not just on the land, but on the memory of a young nation, demanding an explanation for the forces that could reshape the very heart of America. Beneath the quiet fields and small towns of the central Mississippi Valley, a hidden scar runs deep through the bedrock. This is the Reelfoot Rift, a failed split in the continent that stretches from Arkansas to Illinois. More than 500 million years ago, forces inside the Earth tried to pull North America apart here, but the rift never fully formed. Instead, it left behind a zone of weakness, a geological fault line buried beneath layers of river sediment. Over countless centuries, the North American plate has pressed against itself, squeezing the ancient rift millimeter by millimeter. Unlike the restless edges of the San Andreas Fault in California, where plates grind past each other in near constant motion, the new Madrid Seismic Zone sits in the stable heart of the continent. Yet it is precisely this stability that makes the region's earthquakes so unpredictable and far-reaching. Stress accumulates slowly, with little warning, until the old wound in the crust finally gives way. When that happens, pent-up energy is released in a sudden jolt, sending seismic waves racing outward. Scientists compare the rift to an old scar on a bone, mostly healed, but always vulnerable. Today, satellite measurements confirm that the ground is still shifting, if only by a fraction of an inch each year. The buried rift remains restless, and its slow but relentless compression is the reason geologists monitor this zone so closely. The same forces that shaped the land centuries ago are still at work, deep beneath the surface, loading the fault for whatever comes next. Sensors buried deep beneath the Mississippi Valley record a steady pulse of movement. Since the 1970s, more than 4,000 microquakes have been detected along the new Madrid Seismic Zone. Tremors too small for people to feel, but unmistakable to the network of seismometers maintained by the U.S. Geological Survey and university partners. The data reveal a pattern. These tiny quakes cluster along the ancient rift, tracing its zigzag path from Arkansas to Illinois. Each recorded event adds a new dot to the seismic map, showing that the fault system is not dormant, but active. Modern global positioning system stations, anchored in fields and on rooftops, measure the ground's subtle drift, sometimes only a millimeter per year. Even this faint motion signals that the crust is under strain, slowly compressing as tectonic forces press against the old scar beneath the surface. Scientists track these shifts with high precision, comparing years of satellite data to spot the slow buildup of stress. In the past 12 months alone, over 200 minor earthquakes have been logged, matching the long-term average and confirming that the fault remains unsettled. A U.S. Geological Survey seismologist described the findings in an archival interview. The measured locations of these microquakes let us identify the active faults. The trends are clear. Seismicity is concentrated in 4 main segments. This clustering, mapped in real time, acts as a warning sign. The numbers on the screen are not just statistics. They are evidence that the same forces which shattered the land in 1811 are still at work, reloading the fault for another possible rupture. Scientists studying the new Madrid Seismic Zone warn that the region is capable of producing earthquakes as powerful as magnitude 7.5 to 8. These numbers are not just theoretical. They come from modern United States Geological Survey projections, informed by the scale of the 1811 and 1812 events, and by what the fault system has revealed through decades of monitoring. The real danger extends beyond the strength of a single earthquake. In the central United States, seismic waves travel through ancient dense bedrock. This geology acts like a bell, carrying the shaking far beyond the epicenter. In fact, seismic waves here can move up to 5 times farther than they do in California. This long reach creates a long reach effect that amplifies impact. A quake of this size would not simply devastate one city. Instead, it would send shockwaves across hundreds of miles, rattling buildings and infrastructure across the Midwest and lower Mississippi Valley. During the early 1800s, people felt the ground move in cities as distant as Boston and Washington, D.C. Today, the same pattern would play out on an even larger scale, with modern urban areas facing simultaneous impacts. The reach of a new Madrid earthquake means that Memphis, St. Louis, Nashville, Little Rock, Louisville, and even Chicago could experience damaging shaking at the same moment. This broad impact is not just a function of distance. The soils and sediments of the Mississippi Valley amplify ground motion, increasing the risk of severe damage to structures that might otherwise withstand a quake of similar size elsewhere. The hazard is not confined to a single point on the map, but radiates outward, turning a regional fault into a national threat. The numbers alone make clear. The new Madrid Seismic Zone holds the potential to shake the heart of America on a scale few other faults can match. Downtown Memphis sits atop deep river soils. Its brick buildings and aging bridges face a silent threat. FEMA's earthquake simulations show entire blocks could collapse, plunging neighborhoods into darkness as transformers fail and power lines snap. A FEMA planner warns that most of what stands today wasn't built for this level of shaking. In St. Louis, engineers have long noted that the Gateway Arch, though iconic, was never designed with major earthquakes in mind. The exact response of the arch remains uncertain, but the city's unreinforced structures and riverfront districts are highly exposed. Across both cities, thousands of bridges and pipelines cross ground at risk of liquefaction, where the earth turns to liquid, swallowing roads and rupturing water mains. Soft soils could undermine foundations and leave whole neighborhoods isolated. A civil engineer points out that our critical lifelines, bridges, hospitals, power substations, are only as strong as the ground beneath them. In a big quake, many would fail. A major earthquake in the new Madrid Seismic Zone would ripple far beyond the epicenter. The Mississippi River, which carries 500 million tons of cargo each year, could grind to a halt, choking supply chains across the country. FEMA models predict more than 80,000 people killed or injured, and more than 2 million forced from their homes. The economic toll could top $30 billion, making it the costliest natural disaster in United States history. Yet the region still lacks robust early warning systems and the strong building codes found in places like California. Without urgent action, upgrading infrastructure, enforcing seismic standards, and expanding monitoring, the next big quake will turn a regional crisis into a national catastrophe. Over 2 million people live atop the new Madrid Seismic Zone, most in buildings never designed for major quakes. As pressure builds beneath the Midwest, the next rupture isn't a distant threat. Preparedness isn't optional. In this region, the ground's silence is never its promise.